Okay, so this is a tutorial on polynomial division, and we'll just start with something like, let's say, 3x squared minus 2x minus 8 divided by x minus 2. So that's the sort of thing I want to work with. I've already had a look at this before this video, and I know that there's going to be no remainder from this division because this perfectly factorizes. This isn't a prime. So how are we going to go about this? Well, first of all, let's just think about how we would do this with ordinary numbers. So if I chose some numbers like, let's choose something like 182 divided by 14. There are various ways, as we know from earlier videos, the various methods that we can use to complete this calculation. Okay, the method that I want to think about later on, probably in a second video, is going to be long division, where we use a bus stop method and we write it out something like this. Okay, 182 divided by 14, and we end up dividing the 14 into the 18 to 1 times 14. We put the 14 underneath here. We subtract this 14 from here to get 4, bring down the 2, and then we have 3 times 14 gives us 42 and no remainders. So that's the long division method, and it works brilliantly, and it's the conventional method for algebraic division. Okay, kind of standard algorithm. But what I'm also going to think about and going to concentrate on in this video is a grid method that comes out of multiplication. So if, for example, I write down, I draw out a grid like this. Okay. And say, well, x minus 2, that will be one of my multiples here. And it would be multiplied by something else to give me my answer, 3x squared minus 2x minus 8. So in that case, 3x squared minus 2x minus 8 would be the product of two binomials. But right now, this is the dividend, and the other binomial here is the quotient that we want to find. So can we fill in this box? Well, it's a bit tricky because 3x squared minus 2x minus 8, there are 3 terms here, and there are only, there are 4 boxes. And that's because this middle term, minus 2x, is kind of split between these 2 boxes, and then when it's totaled, we would get minus 2x. So at the moment, we don't know what we would write in these 2 boxes here. We do know, though, that whatever this term, this x term here, is multiplied by this x term, it will give us the answer 3x squared. And we know that whatever, that this final term, minus 8 here, times whatever this term here is, times minus 2 will give us this answer, minus 8. Okay? And that's all we need to know, in fact, because all we do now is say, well, 3x squared divided by x will give us 3x. So 3x times x gives us 3x squared, so that must be correct. So we've already got one of our terms, and we can get the other term, the last term of the quotient, from these 2 figures here. So minus 2 times whatever the last term is will give us minus 8. In other words, minus 8 divided by minus 2, well, that must give us plus 4, because 4 times minus 2 is minus 8. So our answer to 3x squared minus 2x minus 8 divided by x minus 2 is this, 3x plus 4. So grid method works extremely well. If we try something a bit more complex, let's just erase these so we don't get confused. So I'm now going to try, there we go. I'm now going to try grid method with a few more boxes. I've written out again, before this video, a problem that I know will work out perfectly without any remainders. And in a later video we'll deal with division if having remainders is fine. But for the moment we're dealing with division without remainders. So I've written out this one. Let's see, 4x squared plus 8x plus 3. Oh no, that's wrong, sorry. Let's just erase that. There we go. Apologies for that. So 4x cubed plus 4x squared. So we want a cubic, not a quadratic. Nice long cubic. And we're going to divide that by x minus 1. Okay. Whoops. There we go, making a few mistakes. But I like to keep these mistakes in because I like you to realise that we all make mistakes, and that mistakes in fact are quite useful. They're a good way to learn. So x minus 1. How would we do that? Well, this time, if we think about it, we've got a cubic 4-term polynomial here, divided by a binomial. What are we going to end up? We're going to end up with a trinomial, in other words a quadratic expression, and that's going to be our quotient, which will appear here. So that's going to be 3 terms multiplied by 2 terms to give us this what would be the product, but this 4-term polynomial up here. So it's going to be 3 times 2, giving us 6 boxes. Okay. So 1, 2, 3, 4 lines to give us, there we go, 6 boxes. And if I write my x minus 1 on the right hand side instead of the left hand side, it will make life easier, and I'll show you why in just one moment. So now we can start filling this in. 4x cubed has to go there. So whatever we multiply by x, the 4x cubed must appear here. So we know that's going to be 4x squared, because 4x squared times x gives us 4x cubed. We can also fill in this one because we've got our final term here, minus 3, and minus 3 divided by minus 1 will give us simply 3. So our last term is here. All we've got to do now then is fill in this middle term. But it's a little bit more complicated than we have over here. We do have to fill in some of these boxes. Let's see what we can do. Well, the reason why I put this on the right is to do with this method, which I got from James Tanton. James Tanton's got a YouTube presence. He's also got his own website, and he's a quite well-known Australian, I think, maths educator now living in the United States. So it's really his diagonal idea here which helps us to complete this problem. I'm going to fill this one in before I do anything else. I've got 3 times x giving us 3x. And I'm going to fill this one in, 4x squared times minus 1, in other words minus 4x squared. Now here's where James's method comes into its own, and it really does work out brilliantly. What he's pointed out is that these diagonals here have to add up to this term here, because these are our x squared terms. So minus 4x squared plus something must give us 4x squared. Okay? Now, similarly, 3x add something else will give us minus 5x. But I don't actually need to worry about that yet, and I might not need to worry about it at all. Let's see how this goes. So first of all, 4x squared is the sum of minus 4x squared plus this unknown here. So this unknown here, well, it must be 8x squared. Okay? And now I can try to fill in the rest of my box. So I've got 8x squared. 8x times whatever this is gives us 8x squared, or 8x squared divided by x. So we end up with 8x here. Okay, and now I've finished. I don't need to fill in this box here because I've already got my answer. And so my answer is 4x squared plus 8x plus 3. Okay? So, thank you, James, for that method, which we can call the tangent method. The way he teaches it, he does complete these boxes, I think. And so let's just have a look at that. Let's see. So if we wanted to complete this, we would say that diagonal there would give us our minus 5x. We could think of this as a diagonal of 1, which gives us our 4x cubed. And this is our minus 3. But I think this is turning the tangent method into an algorithm, and that is what we want to avoid, because we want to understand maths, not follow mindlessly algorithms. So I'm going to avoid doing that, but just for the sake of demonstration, 3x add something gives us minus 5x. In other words, this must be minus 8x here. So that just completes that. And here, of course, we've got 3x minus 2, so it's minus 6x, and 4x in this box here. Okay, so grid method works extremely well, and I do recommend you going to check out James's videos. I think he calls it Good Day Math, if you want to Google it, so that you can see how this works with very large polynomial expressions as well. All right, finally, what I want to do is just demonstrate how algebraic long division works, and it's pretty straightforward, but it can take a little bit of time. Let's just have a look. So drawing our bus stop here has to be fairly long to fit in the whole expression. We're using the same terms here so that you can compare the grid method to the long division method. All right, so we've got 4x cubed plus 4x squared minus 5x minus 3. Now what we do here is we take our first term here, x minus 1, and we divide it into 4x cubed. Now we're not going to forget our minus 1. We're going to come back to that, but the method is to use the first term, in this case the x term. Okay, so x into 4x squared, so we get our 4x squared. I'm going to place it up here, you don't have to, but it seems nice to line it up. And then just as we did with traditional long division, we multiply back out again, but this time include this term. So we have 4x squared times x gives us 4x cubed. Minus 1 times x squared will give us minus 4x squared, and then we subtract this term from the term above here, just exactly the same as we did with our conventional long division. So 4x squared minus 4x squared gives us 4x squared plus 4x squared, in other words 8x squared. Again, we bring down the next term, just as in the traditional method, and so now we have to follow those steps again. So x into 8x squared will give us plus 8x. Multiplying out, we get 8x squared minus 8x. Subtract bottom from top, and we end up with, well, minus 5x minus 8x is minus 5x plus 8x gives us 3x here. Bring down our final term, minus 3x now into 3x gives us plus 3, and then multiply out again. We should have no remainder. Okay, so that's our long division method. It will also work, and this is the advantage of the long division method, it will also work if we get if we want to include remainders, so it will work for anything, whereas this method here, because it's an area method, will only work if there are no remainders. So that's a limitation to that grid method. But as long as we know that we're working without remainders, then the grid method seems better, seems quicker, more intuitive, perhaps easier to understand, and it works very nicely. Now finally, there's something called synthetic division, which is very popular, and it's popular because it's much faster than grid method. So I'm just going to show you that now. And what we do with synthetic division is we take the coefficients here and we write them down instead of all these x terms. So it's a way of just working a lot faster. So the coefficients are these multipliers that we have in front of every term, and so we have 4, okay? And we'll write down 4 again. No pluses, minuses, just the terms themselves. We have minus 5 here, though, because we have to register that that's a negative. And we're going to use the minus 3 here, which is our final term. And then what we do is we put a little L shape here. And this time with synthetic division, the difference really between synthetic division and long division, the major difference is we're using the second term in the binomial to multiply through. So to divide through rather. So we write our minus 1 here. Sometimes people very often conventionally change the symbol here, but I don't see the necessity for it, so I just put down the second term, minus 1. Now, to start the process, and it really is an algorithmic process, so it's very difficult to understand how it works, so we just bring down this 4. So the 4 comes down here, and we put it underneath. Okay? Now what we do is we say minus 1 times 4 is minus 4, and we put minus 4 here. Okay, 4 minus minus 4, so just as in the long division here, we're subtracting. So 4 minus minus 4 is 4 plus 4, so we get 8. That in fact is our 8x squared term here, or our 8x rather up here, our x term. But anyway, let's come back to that. So now we have minus 1 times 8, so that goes up here, that gives us our minus 8. So now we have minus 5. Minus minus 8 will give us minus 5 plus 8, giving us 3. Okay. Finally, we have minus 1 times 3, which gives us minus 3. So we put our minus 3 there. And we've got minus 3 minus minus 3 is minus 3 plus 3, so that's 0. And we'd expect that because this last term here is in fact our remainder. These are our x squared terms, our x terms, and our constant at the end. So that's how we would then derive the answer 4x squared plus 8x plus 3 with no remainder. So that's synthetic division. Synthetic division. And it works very nicely. It's a very useful, very helpful method. But a bit obscure and difficult to understand until we compare it to the long division method. Long division method's a lot longer, but what happens is a lot of these parts of the long division process are stripped out of this calculation using synthetic division. But if time isn't an object, then the standard algorithm, long division, is the basic idea that works extremely well. Okay, so that's 3 different ways then of dividing terms like this, and the only thing to note is that synthetic division actually doesn't work if we don't have a monic term here, a term here which doesn't have a coefficient, or that is, if it was a quadratic it wouldn't work in this format. So synthetic division gets actually rather complex when we don't have anything as simple as dividing x minus 1 into a term. Nevertheless, it works for a lot of situations, so it's a good method to learn and to know how to use. Okay, I hope that's helpful. So lastly, I just wanted to put up some algebra tiles because this is a very good way of just looking at the grid method that we've been using purely visually without putting the labels in, just seeing what's going on using this visual method. So we've got here 4x squared plus 14x plus 12 divided by 2x plus 3, and I've filled in this area here then in an exact rectangle, so the whole area is filled, which means we won't have any remainder. And this represents this dividend here, so we've got 4x squared tiles, and the same length as one of the sides of the x squared gives us our x tile, so we've got 14 of those, plus 12 ones fitting in here. So this area here represents 4x squared plus 14x plus 12. And so on the left here we've got our divisor. We've got 2x plus 3 ones, so 2x plus 3. And just like the grid method, we can then put some more tiles up the top here. So the side that hasn't been used here becomes our answer. So that's our quotient. And if we fill that in, so we'll be able to, we can already see, we'll be able to put an x tile there, so another red one, another one here, and then here we'll just fit in 4 ones. So that's our answer. Let's just write that in. 4x squared plus 14x plus 12 divided by 2x plus 3 must be 2x plus 4. And what I also want to show you is how a term here which has 2 coefficients, so the x term is 2x, something that's tricky to do with synthetic division works very nicely with long division. So let's just write this out. Okay, so our dividend goes underneath the bus stop. Okay, like that. Now we divide into the first term here with the first term of our divisor. So 2x into 4x squared is 2x. Whoops, I forgot to put my x term there. So 2x up the top here, and then we multiply out. So 2x times 2x gives us 4x squared. 2x times 4 gives us 8x. Subtract, and we get 14x, subtract 8x gives us 6x. By the way, we might want to just remind ourselves that this is minus both these terms here, so I put those in brackets in case we're tempted to add here, but it's subtract 8x from the 14x, gives us our 6x, bring down the 12, and then again the 2x into the 6x gives us our 3. So we have 3 times 2x is 6x. 3 times 4 gives us 12, and we've just shown that we've got no remainders. So our answer is 2x plus 3. So that's when we divided this term here. So we made this now our divisor, and our quotient then comes out the other side here. Whoops, let's just bring that right down. Our quotient is now this term here, which is 2x plus 3. Finally, I just wanted to compare this, just for interest, with conventional long division. So let's go back to this division here. If we have x equals 10, okay, then 2x plus 3 will become 23. And let's divide that into, well, what have we got? We've got 400, because x is 10, so x squared must be 100, so 400. 400, let's write that in, 400 plus 14x, well that's 140 plus 12. And so what we're going to get here is a bit of carrying. That 12 is going to be give us just plus 2 at the end here, and so one of our x's goes into that column there. Here we've got 100, so that 100 will go into the hundreds here, and we end up, after that little bit of carrying, with 552. So this sort of thing that happens with ordinary numbers, let's make sure that's clearly a 2, it looks a bit like a 1, 552. And we'll see that that produces some interesting effects afterwards as well, which again don't happen in the algebraic log division. Let's work it through then. So 23 into 55, well we could say 20 into the 50 here, just as we do up here. And so there would be 2 2's into that 5, so we say 2, so there's our 20. Multiply out then not just the 20 but also the 3 here, so 2 23's giving us 46. Now here's where again it differs from algebraic long division in that we want to do a bit of borrowing here. So we're subtracting 46 from 55. We have to now borrow 10 from there, leaving us with 4. We add the 10 there to give us the 15. 6 from 15 gives us 9. So 46 from 55 gives us 9. Bring down the 2 and 23 into a 92. Well, again, we can divide the 2 or the 20 here into the 90, which goes 4. So we have 24. So there's our answer, the 24 appearing. If we multiply out, we've got 4 times 23. Well, that's 2 times 46 gives us our 92. There we go. Subtract 92 from 92, and we've got no remainder. So an interesting comparison to make with conventional numbering, but the main thing is to understand very thoroughly the long division method, because that really is the most reliable and the useful method that we're going to use, but also not to forget the importance of the grid method. Now in a later video what I'm going to do is offer some tips about practicing, especially this long division method and the grid method. So you want to look up that one, and I'll show you how to actually generate some of these problems without having any remainder. Let's do it all together.